And this is the way the ethical hackers do it as well. So for the web server assumes there's going to be a browser here. It assumes the browser is going to behave the way browsers behave. Well, those assumptions are going to be the weak points, because by putting a proxy between my browser and the web server, so a request goes from the browser to the proxy to the web server back to the proxy, and then back to the browser. But I can stop the request, or I can stop the response, modify that in flight, and then let it go on. Okay. So if the server sets a cookie, I can change that cookie before it gets to the browser, right? Or if the browser has JavaScript that restricts, you can only enter numbers and numeric values here, I can stop that value here, change it to anything I want before it gets to the server, and then goes on to the server. So any kind of client validation here is going to be totally ineffective, because I can change it after it gets outside the browser. But it gives the convenience to the tester, because I've got a browser here, and things kind of look like a browser. I have to look at the raw HTML and the raw data. I can just kind of pull out the pieces I want to inspect, the pieces I want to change, and then modify those on their way to or from the server. Does that make sense? Very powerful tool. A lot you can do with that. Okay, so kind of to summarize the defenses. Web application security always starts with your architecture and design. There's really no replacement for doing secure architecture. You can't add security later on. So many places will say, look, we've developed this application, we didn't have time for security, it's in production now, can you test it for us, right? Well, if they're testing it now and you find vulnerabilities, you're not going to take the application down, at least most of them aren't, at that point. So, and also, if you've already got it in production, and we say, well, wait a minute, the architecture's wrong, we've got to change how it's architected, we've got to change some of the framework, how it's communicating with other parts of the application, right? Those are fairly major changes that are real expensive to do after you've already been in production. It would have been pretty easy to do if you'd done them earlier in your software development lifecycle. Again, application security vulnerabilities are not prevented by the traditional security controls. Antivirus, firewalls, those kind of things are not going to help you out here. Also, as engineers, we like to invent stuff. We like to build stuff, right? So we tend to, hey, let's write our own crypto system. Let's write our own authentication system. Those things tend to be big gotchas in application security. So when you do that, it's not going to be done right. And you stop to think that even Bruce Schneier, every time he invents a new crypto cipher, he has a whole team of people working on it. Not every one of those turns out to be good. Some of them turn out to be flops, right? So someone who's brilliant as him can't get it right every time. Then I don't think we should even try, is our thought. And also, for crypto systems, you really want to have them out there in the industry and accepted and tested for years before they become accepted. So what you do is you set your security policy. Hey, look, if you're going to encrypt something, you've got to use one of these approved algorithms, and you have a list of algorithms that you already know to be saved. So the big thing about overall application security is we don't spend enough time on design, and we don't spend enough time on test, right? So you want to design, code, and then test, right? With the emphasis on more on the design and more on the testing. We also just want to write the code and get it out there and see it work. All right, you with me so far? Great. All right, so let's talk about client-side attacks. Those are the huge trend that we're seeing as well. And these two trends will work together, and we'll see how that does. So for client-side attacks, we're going to attack the user's browser, email, right, and also their media handlers, right? Adobe Flash, Adobe PDFs, Microsoft Office. All of those handlers of attachments or images or things that can be sent as part of the HTML are going to be attacked, as well as the browsers and the email clients themselves. So, and just the complexity of all the things these things have to do, right? I mean, Adobe and Microsoft and everybody else is always building in new features and new functionality into their PDF readers, the Adobe Reader, right, and the Microsoft Office documents. And a lot of that functionality can be used against you. So obviously, just having hardening security controls on your servers isn't going to help here, because they're attacking your clients. So the reason for attacking these is there's a lot more clients out there, right? And the clients do not get the security scrutiny from the security department that the clients do. And certainly there's also home systems, right? Home systems with broadband make a fairly reasonable member of a botnet. So they're useful as well. So clients are easy targets, and they're going to be one of the primary targets of the attackers. Questions? Yes? How can what?
How can SSL defray some encryption, if at all?
It does help. SSL provides encryption of your data from your client to the server, right? Also, if you're careful, it can authenticate the server. It authenticates the server to the domain name, right? If you have the wrong domain name, then you're authenticating the wrong thing. But so there's still things that can go wrong. There's also SSL man-in-the-middle attacks, but you should be getting warnings for those. So yeah, SSL helps. It's not a silver bullet in itself. You know, you see these ads, you know, secure your servers, use SSL. Well, yeah, SSL is a good thing, but it doesn't secure your servers all by itself. Good question. Anybody else? All right, so how is the attacker going to attack the clients, right? Well, the clients, you know, you can't connect with them directly, right? Usually they're behind firewalls and stuff. So to attack a client, what you need is you need a malicious server. And so this is where the web application vulnerabilities and the client attacks work well together, right? They can go out, compromise the web application, put malicious stuff into the web application, and then use that web application to attack the clients. And so they really work well together. So the other problem they have is, okay, we've compromised the server, we've put the malware up there, right? So the good guys figure out the malware is getting downloaded from the server. They go out, find the owner of the server, do a takedown of the server, and clean up the server, right? So, okay, well now the bad guys are kind of out because they need to set up another server. So how can they keep their servers from being identified and from being taken down, right? How can they do that? Well, we've really got like 3 solutions with redundant servers that they've been using. So one thing they can do is hack into legitimate servers, right? And there's lots of them out there. As long as they get lots of legitimate servers with their malware on it, that'll work for them. Something that's come up in the last couple of years, they actually go out and buy ads. I mean, they're getting enough of an economy here, so they got a little bit of money. And an ad's not that expensive these days. So they buy an ad and put some malware in the ad. And they actually don't put the malware in the ad. They put JavaScript or links in the ad that's going to direct the client to download the malware, right? But that's good enough. It gets them where they want to go. So there's actually been a little bit of that, which is pretty interesting. A third solution, which is really cool, is called fast Flux service networks. And this gives them an array of servers that's redundant. And we're going to look into that in the next couple of slides. So with fast Flux, you actually have a cooperating network of redundant servers that have been compromised. You know, they didn't have to pay for the hardware, they don't have to pay for the hosting of the internet service. And what they do is they set up a DNS name with hundreds of IP addresses. And these 100 IP addresses get swapped out, kind of round robin style. So when the client resolves, badguy.com, right? The names aren't going to be that obvious, obviously, right? But when a client that the attacker is attacking resolves that name, it could go to any one of these IP addresses, and there's more than 100 of them out there. Okay? So then to really make this effective, that means we have to take down all of those servers, right, and not just one of them. So it really increases the amount of work we have to do in order to clean up, to prevent the malware from being loaded. So these IP addresses are constantly changing too. So every time as the white hats, we resolve the name to an IP address, we see a different IP address, right? So we see a whole list of IP addresses that we're going to have to go after. So that creates a lot more work. So basically, they have this highly redundant, highly reliable, array of servers, right? Doing low distribution, right? It does health check. If one of the servers stops responding, it takes that IP address out of the list and automatically adapts for it, right? Kind of like professional grade, reliability here. They got better infrastructure than we do, don't they? Go ahead.
Why not take down the domain name?
Take down the domain name. Great idea. We'll get to that next. Super question. I love that one. So if one server doesn't respond, the IP address is automatically going to remove from the network, right? So they're going to update this. So this is fast Flux network. They have a second layer of servers behind the first layer. So the first layer is just proxies, right? And the other servers behind it are the ones actually serving up the malware. So the frontline servers don't have any malware on them. So we look at these IP addresses, say, hey, look at, you've got malware you're downloading to our clients here, you're attacking us. They go look at the server and say, no, there's no malware in here, right? Because all the malware is on a second layer behind them. I mean, there's malware in the sense that there's software running on it that shouldn't be running, right? But it's not the same malware that the clients are getting, right? So when we point at a particular name or version of malware, it's not going to be found on that server. So these backend servers are then actually hosting for the malware. So this makes the attacker's job a little bit easier because they need fewer of these servers, right? They actually have the malware. You can change the malware a little more quickly instead of having to change that on hundreds of servers. And the other servers are just kind of dumb proxies that proxy out the malware. Again, it takes it very difficult to take down the network. So, and of course, there's a Flux mothership. Basically, this is the command and control center. That's like the third layer that sits behind all those second layer servers that serve up the malware. Now, this is called single Flux network, right? So, we've got multiple DNS servers quickly swapping out IP addresses, right? When they're swapping them out like a 3-minute time to live. So the good question is, well, let's think about this. Well, let's go take out the DNS servers, right? Because they're serving up these IP addresses. So the single Flux network has just a few DNS servers that are doing that. 10 minutes, thanks. But there's actually a double Flux network that solves the problem of what about the DNS servers? That's kind of not a single point, but a narrow point of failure for the service. So what they do is they replace all the traditional DNS servers with fast Flux layered DNS servers. So now instead of having just a few DNS servers, we can have a ton of DNS servers, and the IP addresses for those DNS servers are changing fairly frequently, within minutes anyway. So then when we take down one DNS server, there's other ones out there that are just filling in and replacing the other DNS server. Now, in order to do this, they have to make fairly quick registration changes. So they're looking at, well, wait a minute, do we really need to have registrars that process registrations every 5 minutes? Maybe we don't really need to change that quickly, right? So they're looking into ways of preventing the fast registration changes, because the registration points to the DNS server. The DNS server then points to the name to the real IP addresses, or the set of IP addresses. So basically, having a double Flux network kind of eliminates the vulnerability point of being able to remove the DNS servers, because there's an array of DNS servers out there, and each one will fill in for the other one as they're taken down. Did that answer your question? Pretty cool, huh? Wish we had toys like that. All right, so we got 10 minutes left, less than 10 minutes left. So one of the tools they use is mpeg. I'm not going to spend a lot of time on this, but it's commercially available. There are some free versions out there. But basically this sets up on a web server, allows them to kind of monitor their botnet and get statistics out of it. So another tool, askprocs, combines several attacking techniques. I did want to kind of walk through this one. So this one uses Google hacking, right? And Google hacking is searching for vulnerabilities through Google, okay? So how this would be done is they say, oh, we found this particular framework, and if application developers use this framework, they're likely to be vulnerable to this to SQL injection. So you search for that kind of vulnerability in Google, find sites that are using that particular framework, and then they attack those systems. Okay, so that's Google hacking. Instead of looking for a vulnerability on a server, it's looking for a server that has a known vulnerability. So then they do automated SQL injection on those servers. And the automated SQL injection, now this is a custom application, right, written for this particular thing, but it's using a known framework. So what it does is it queries the metabase, or the sys objects, and the sys object is kind of the database about the database, right? It has the list of database names, table names within those databases, all the field types and all that information. So by going to the metabase, or the sys objects, it can find out what are the tables to query. And then it starts querying all those tables, and specifically picks out all of the fields that are varchar, the variable length character fields. And it takes all those fields and tries to inject SQL queries that'll actually update those fields and add JavaScript to those fields. So now it's modifying the database, putting JavaScript into every text field it can. And the JavaScript, of course, will generate URLs that'll send clients to their malicious web server. So this is called cross-site scripting, because they're injecting JavaScript into the database. The JavaScript then runs in the client browsers, redirects the client browser to download some malware. This is usually done through iframe redirection. So an iframe is just a built-in frame on the browser, but it can be made very small, right, and transparent. So basically the JavaScript then runs in that iframe, goes out, grabs the malware, downloads the malware, and the malware is installed on the client. Okay? And then this tool also uses a fast Flux service network in order to keep the servers redundant. So the browser downloads the askprocs agent basically at that point, and they become another member of the botnet. Any questions on that? So you see that flow, right? You go, all you have to start with a known vulnerability, Google search for it, and have it start attacking those vulnerabilities. And specifically, we have to look for a SQL injection vulnerability in this case. All right, so again, for traditional client defenses, there's no silver bullet. There's a lot of things that can be done. patching and hardening is important, but it's not going to prevent you from most of these attacks we talked about. Host-based IPS is very helpful. It can be kind of get in the way a lot of times. So a lot of places either don't use it, or if they do use it, they don't configure it to be the most secure, least convenient. Host-based firewalls are helpful, of course. Endpoint security. Again, these are controls that are kind of, I think they're still a little green. I mean, because to do their job right, they get really inconvenient, and then people turn them off. So we haven't found a good balance of making them do their job without getting in the way. Browser reputation phishing filters are all useful. Network intrusion prevention will help as well. So some of the newer client defenses, again, this is really a developing area. New clients, the browsers are working on developing new things. Chrome in particular, I think, is making a valiant effort. Better sandboxing, safe browsing. Internet Explorer has added some things into it last time to help. ActiveX improvements. Based on when you run an ActiveX control, that control is running with the same rights as you. It can do anything to your computer you could do to it. Firefox plugins help a bit, but these kind of get in the way as well. At least some time for questions at the end. So again, these are some of the organizations I'm involved with: Southern Tier ISSA, Rochester ISSA, OWASP, and of course the Rochester Security Summit that we have in October. So, any thoughts, questions? I'll leave some time for that. We'll start on this side and we'll sweep around.
I'm just wondering which browser you consider to be the most secure.
Yeah, I get that question all the time. It really depends. I mean, with Firefox, if you're a techie and you don't mind the tools, I love the security tools that Firefox has. Lately, Firefox has been pretty buggy, so I'm moving over to Chrome. The Chrome sandboxing is really a nice feature. So I think for the average user, I'd probably say Chrome. For someone that's techie, it's probably they need to figure it out themselves. But in either case, it's probably not IE. And, who's next?
Everything's built on top of IE.
Yeah.
So you don't have a choice.
Oh, right. Like Windows Update and stuff, you really have to use IE. And some websites you really have to use it.
Well, sometimes you can just use the developer tools and tell it to emulate IE. So it thinks it's IE and it doesn't let display it.
Yeah, I haven't had luck with that. Have you?
Oh, yeah.
Okay. Because sometimes, I mean, the server thinks it's IE, but then it still doesn't quite work the way the IE works, So, I don't know. All right, who's next?
Using something such as defreeze on one of the machines, with that.
Using something such as what? I'm sorry.
Defreeze.
Defreeze.
Which locks which basically locks the desktop, so as soon as you restart, it comes back to a fresh version.
Oh yeah.
Would that help keep botnets from? So let's say the machine
Yeah, it
was
would.
infected.
Right, because any malware that's downloaded then wouldn't be installed permanently, right?
Right.
And even if they could have Java or JavaScript running in your browser, that might be malicious while it's running, but once you reboot it, you'd be cleared from it. Again, that's a great control. It gets a little inconvenient, but it's probably one of the best controls out there. For if you could kind of keep your maybe your banking, do your banking only on something that never gets changed or something, then do your because there's 3 levels of risk, right? Your banking is your highest risk if you do any kind of web banking, and then your general browsing and email is your next one, and then maybe have another system for doing your work where you really want information protected. But again, you can have VMs for that or do something like defreeze.
How do you get across to users that not to click on emails?
Oh, awesome question. To tell you the truth, I've given up on it because I think that's our job as security professionals. No, I mean, because really, we've developed an email system that the from address can be anything you want, right? The content can be anything you want. I mean, some of the phishing emails have really gotten very sophisticated, and who can tell the difference, right? I just heard from a couple of security professionals. They're well known, and they got phished, right? Because they got something that looked legitimate, and they clicked on it. So I think teaching people to detect phish is a losing battle, right? We've got to invent authenticated email or something and solve the problem that way. It just isn't going to work any other way. But excellent question. That's one of my soapboxes. So there is no solution, right? Other than set up encrypted authenticated email, and then then the user knows it's really from John Doe, because only John Doe could have signed it and encrypted it, right? And that would be a big step in eliminating it. Go ahead.
Do you have any suggestions for the web app shop of one? Because I can't design, I can't test and code and get anything out the door in any sort of reasonable time frame.
Yeah.
Besides hiring more people, which is not